The recording. So back to our presentation. And this is an example of a class person UML diagram, which has name and address. Both are strings, and we have get name, get address, and set address as a a set of getter and setter methods. And you can see I'm also trying to use minuses to show that the data is private, and pluses that indicate that my methods are public. So there's some, again, video notes here, which I also posted a while ago. You can take a look at that. Instead, I will talk a little bit about this stuff, in our, using our Violet tool. Okay, so here's our Violet tool. And so a number of things. We just want to say that if we can write classes in our code, after all, these class declarations or definitions, I need to really look up what Java technical documentation refers to it. I sometimes alter declaration definition because in C++ you can have separate declaration and separate definition, or both together. In Java it's always sort of like a complete definition of a class. But if you look at this entire file, it's nothing else but a sequence of data attributes and methods. Each method has its own kind of body of the method, which is, we know, formulated by using block statement with opening brace and closing brace, and then some executable statements in between using the proper syntax and semicolon. This is not big concern of our today's class. This is more for our Java discussion, but you can recognize that. But overall, this class definition is nothing more than just a sequence of data attributes and methods, right? So there you go. If we drop all the details, and even simplify it like this, which is quite readable, you can tell anyone that this is the concept that we'd like to use, and the name of the concept is a house. It will have this particular data, and it will have a particular set of operations or behaviors that we can do with this particular class. I can simplify it even more. If I double click on this thing, I can even get rid of this entirely and click OK. This is still a valid UML, because in many cases people will just know what data is associated with the house. And in my particular case, I will be mostly concerned with the set of operations which tell me what I can do with this particular concept. Well, it appears that I can do a couple of sets and a couple of gets. It's kind of not very impressive, but you get the idea. However, even if we simplify it even more, not showing the data at all, assuming that everybody knows what's inside, even in that case, on UML, that section, an empty block with empty data attributes, is mandatory. You cannot, and most of the, not if not most, maybe perhaps all of the UML diagramming tools will always create an empty section if you did not specify the data attributes. Again, so you can, arguably this is more useful in many discussions, especially in a simple concept like this. But UML permits to specify the type of data and also the parameters of methods. And even more so, I could go like full stretch here and say, okay, set returns void, meaning it doesn't return anything. And I have two of set methods here, so I could expand on that. And those already specify what they return, right? So I can modify it like this. This is what we're going to be using for just for the educational purposes, but in many cases somewhat simplified UML notation is more useful because this becomes hard to read. It almost becomes like a code. The question is, why do we need to capture in UML if everybody kind of guesses what things are? Why is that it is still useful to specify an exact types? For example, to say square feet is an integer, type is a string, and then that set square feet does not return anything, so it is marked at the end as a void method. The reason for all of this is that commercial UML tools, which we saw on that list in the Wikipedia article about UML tools available, is that they're capable of generating code. So basically you come up with the design, and then you go to this magic buttons on your tools menu and hit generate code, and you can even specify what programming language you want to generate that code. It could be, Visual Basic or Java or C++, and you can get that done directly from your diagramming tool. So this becomes very useful. This becomes very very practical. The only problem is that what if someone changes the code that was generated? Then those diagrams become out of date. They become obsolete. They really do not show the true picture. In that sense, most expensive tools will do it also backwards. They can analyze your code and generate UML diagrams from your code. Because after all, look at both of these, right? If you look at this, at those pictures, if you basically look at this and look at the Java code, it's the same thing. You can think of this, file with Java code as a box, right? Just as a box that contains a set of data attributes, those guys, and a set of methods, okay? So there's really no difference. And that's pretty much all that class can have. A set of attributes, the data variables that contain some information about our concept, and a set of methods. So that is, helpful, I think, to understand. What else can I say about, in general, let's talk about the UML. So today we try to mix a little bit of syntax elements and examples, Java examples. Perhaps one day I should try C++ example instead of Java, so that we can see how similar all of this is, and then comparing it to UML. So there will be a couple of homeworks, not too many, where you have to chart, create your own class diagrams. By the way, let me try something else. File new. Well, I guess I would like to talk about those types of diagrams. How about yeah, there. Hopefully you can see them. There was the splash screen which was displaying those in large font. But you can create different types of diagrams because UML, Unified Modeling Language, supports different types of diagrams. Use case diagram is a description of a particular operation that the system supports. Class diagram, we already have an example of our screen. Essentially, boxes indicate concepts. So, for example, I could create a class here and name it a person, right? And same thing, set address and then get address and so forth. It's very easy to create those things, but then remember, I've given my person a house. So UML allows you to display that through relationships. For example, I can use this type of association here and say that person has a house. right? So that's interesting. I will just put this one on the sideline because this was for the demonstration purposes. But this is interesting that UML allows to also express relationships between classes. In this case, it tells us if you have an instance, an object of a person class, well, guess what? Somehow, someplace, most likely in the attribute section, which here is empty, it has a reference to the house object. And so typically if you get access to the person object, you should be able to, without any significant problems, to get to the house, which is related to this person, and also do your work with the house if you need to. So that's what class diagrams essentially are capable of showing. What class diagram cannot show is any dynamics of the execution. For those types of diagrams, we need a different, type of the diagram. Is that we have an activity diagram, and we also have a sequence diagram. Activity diagram typically describes parallel execution. Parallel threads of execution. It's an effective type of diagram. But the sequence diagram is essentially your use case diagram, but expressed in form of what type of objects are used and what exactly is happening. I'll show you some examples of this in our next segment.